Hello everyone, welcome to Principles of Communication System lecture series. In this lecture video, we are going to discuss about angle modulation, frequency modulation, FM modulation index, comparison between narrow and wideband FM, and some examples. We have seen that in amplitude modulation, the amplitude of the carrier is varied according to the amplitude of the information or modulating signal. So in angle modulation, frequency or the phase of the carrier signal is varies according to the message signal. So in angle modulation, frequency or phase of the carrier is varying with respect to message signal. In amplitude modulation technique, amplitude of the carrier signal is varying according with respect to message signal. The standard equation of the angle modulated wave is S of t, it's equal to AC cos theta I of t, where S of t is indicates the modulated wave and theta I of t is the angle of the modulated wave, and AC is the amplitude of the modulated wave, which is the same as the amplitude of the carrier signal. So in angle modulation technique, amplitude of the carrier signal is equal to amplitude of the modulating signal. So for example, you take AM is the amplitude of the modulating signal or message signal, it's equal to 5 volt, and carrier signal amplitude is AC is equal to 5 volt. This angle modulation is further divided into two types. The first one is frequency modulation and second one is phase modulation. The frequency modulation is the process of varying the frequency of the carrier signal linearly with the message signal. The frequency of the carrier is varying with respect to message signal, we call as frequency modulation. And second type is phase modulation. The phase modulation is the process of varying the phase of the carrier signal linearly with respect to with the message signal. So in phase modulation technique, phase of the carrier is varying with respect to message signal. So we call it as phase modulation. Let us discuss these two modulation techniques in detail. The frequency modulation is the process. The frequency of the carrier signal is varying in accordance with the instantaneous amplitude of the modulating signal. So in frequency modulation, frequency and phase is varying with respect to message signal. So in case of amplitude modulation, the amplitude is varying with respect to message signal. So in amplitude modulation, frequency or phase is the constant factor. So here in frequency modulation, amplitude is the constant factor, frequency or phase is varying with respect to modulating signal, and this is the representation of FM, and this is the message signal with respect to time t, and this is the carrier signal, and this is the modulated wave. So this is the instantaneous signal or continuous signal with respect to time t, and this is the carrier signal is continuously varying with respect to time t, and this is the modulated wave. So we know that in frequency modulation, frequency of the carrier signal is varying with respect to message signal. See, so this is the 0, this is the reference point, and this is the maximum amplitude, and this is the phase angle, and this is the negative amplitude, negative peak amplitude, and again this is the positive peak amplitude. So for example, you take this is a 0 and this is pi, and this is 2 pi, and this is 3 pi. So we know that the carrier frequency of the carrier signal is varying with respect to amplitude of the modulating signal. So here, and 0 to pi interval is the positive value, and in positive peak we get the maximum frequency. So we get the maximum frequency, and from year to year, this is a pi to 2 pi, and modulating signal is negative amplitude. So here, so we get the minimum frequency from pi to 2 pi, and again 2 pi to 3 pi interval, modulating signal is positive amplitude. So from 2 pi to 3 pi, so we get the ma- maximum maximum frequency signal. So here amplitude is constant, so it's equal to carrier signal amplitude or message signal amplitude. So for example, the message signal m of t amplitude is equal to 5 volt peak to peak, and carrier signal amplitude is equal to 5 volt peak to peak, and modulated signal amplitude is equal to 5 volt peak to peak. Only frequency is varying with respect to model amplitude of the message signal, and this is the representation of the modulated wave. So we represent S of t, it's equal to AC cos theta I of t, and this is the mathematical representation of the FM modulated wave. The equation of the instantaneous frequency Fi in FM modulated wave is, so Fi it's equal to Fc plus K subscript F into m of t. So this is the instantaneous frequency equation. So where Fc is the carrier frequency, Kf is the frequency sensitivity factor, and m of t is the message signal. S of t is equal to AC cos theta I of t. So this is the FM modulated wave equation. AC is the amplitude of the carrier signal, and theta I is the phase angle. So here we have to find out the theta I of t with respect to instantaneous frequencies. We know that the relationship between angular frequency omega I and angle theta I of Ts. So Wi or omega I, it's equal to differentiation of the theta I of t. The angular frequency omega I is equal to 2 pi into instantaneous frequency, and instantaneous frequency we represent in terms of f subscript I. Just you replace omega I into 2 pi f. So we know that omega is equal to 2 pi f. So angular frequency omega I, it's equal to 2 pi into fi. So it's equal to 2 pi fi is equal to differentiation of the theta I of t. So here instantaneous frequency fi, it's equal to 1 by 2 pi into differentiation of the theta I of t. So our main intention is to find out the theta I of t. So here theta I of t is in the form of differentiation. We have to extract the theta I of t. So then you take the integration on both sides. So take the integration on both sides. So here 2 pi is the constant factor. So here, so we know that integration and differentiation is inversely proportional. So differentiation and integration is get cancelled, and here 2 pi is the constant factor. So theta I of t, it's equal to 2 pi into integration of instantaneous frequency fi into dt. So this is the theta I of t in terms of integration. Then you substitute the fi values into a above equation. So we know that Fi is the instantaneous frequency. It's equal to Fc plus Kf into m of t. The Fc is the carrier frequency and Kf is the sensitivity factor and m of t is the message signal. Just you replace Fi of t into Fc plus Kf into m of t. So we get theta I of t, it's equal to 2 pi into Fc plus Kf into m of t into dt. So here the integration, it's common for Fc plus Kf into m of t into dt. So here Fc is the constant factor, you take it outside. Just you rearrange the equation. So it's equal to 2 pi Fc into t plus 2 pi into Kf into integration of m of t into dt. Then you substitute the theta I of t values into a standard equation of angle modulated wave, and this is the standard equation. So s of t is equal to ac cos theta I of t. So now we know the value of theta I of t. The theta I of t, it's equal to 2 pi into fc t plus 2 pi kf into integration of m of t into dt. Just you replace theta I into 2 pi fct plus 2 pi kf into integration of m of t into dt. S of t, it's equal to ac cos and theta I of t, it's equal to 2 pi fct plus 2 pi kf into integration of m of t into dt. And this is the equation of FM wave. In the modulating signal is m of t. So m of t is the modulating signal is equal to am into cos 2 pi fm into t. The am is the amplitude of the modulating signal and fm is the frequency of the modulating signal. And this is the equation of the FM modulated wave. Now we have to find out the modulation index for FM. We know that S of t, it's equal to AC cos 2 pi fc into t plus 2 pi into kf into integration of m of t into dt, where AC is the carrier signal amplitude and fc is the carrier signal frequency and kf is the frequency sensitivity factor and m of t is the message signal. The m of t, it's equal to am into cos 2 pi fm into t. Just you replace m of t into am cos 2 pi fm into t. Then you integrate this. So am is the constant factor and integration of cos 2 pi fm into t. So after integration, the cos and its function is converted into sine. So we know that integration of cos x, it's equal to sin x. So after integration, so we get s of t, it's equal to ac cos 2 pi fct plus beta into sin 2 pi fm into t, where beta is the modulation index. It's equal to change of frequency or delta f divided by fm. It's equal to k subscript f into am divided by fm, and this is the beta value. So here after integration we get the kf into am divided by fm. So kf into am divided by fm is exactly, it's equal to beta factor. So beta is the modulation index. The difference between FM modulated frequency or instantaneous frequency and normal carrier frequency is termed as a frequency deviation, and this is the frequency deviation. The frequency deviation we represent in terms of delta f. So delta f is the product of the KF and AM. So KF is the frequency sensitivity and AM is the amplitude of the modulating signal. So KF into AM is equal to change of frequency delta F or frequency deviation. It is denoted by delta F, which is equal to the product of Km and AM, and modulation index is equal to change of frequency divided by Fm. It's equal to Kf into Am divided by Fm. This is the modulation index. Fm can be divided into a narrowband Fm and wideband Fm based on the value of modulation index beta. So based on beta, the Fm is classified into two types. One is narrowband Fm and another one is wideband Fm. So in narrowband Fm, the frequency of the modulation has a small bandwidth when compared to wideband. In wideband FM, the frequency modulation has infinite bandwidth. So in narrowband, the modulation index beta is small, that is less than 1. In wideband FM, the modulation index beta is large, that is higher than 1. In narrowband FM, the spectrum consists of the carrier, the upper sideband and lower sideband wave. So in wideband, the spectrum consists of carrier and infinite number of sidebands which are located around it. In narrowband FM is used in mobile communication such as police, wireless, ambulance, taxi, etc. In wideband FM is used in entertainment, broadcasting application such as FM radio, TV, etc. Now we will look into some examples. The given problem is a sinusoidal wave of amplitude 10 volts and frequency of 1 kilohertz is applied to a to an FM generator that has a frequency sensitivity constant of 40 Hz per volt. Determine the frequency deviation and modulating index. So they are given the sinusoidal wave of amplitude 10 volts and frequency of 1 kilohertz. So this is the message signal. Sinusoidal wave is the message signal is applied to an FM generator that has a frequency sensitivity constant. The frequency sensitivity constant is K subscript F, it's equal to 40 Hertz per volt. So we have to find out the frequency deviation and modulation index. So first we have to list out the given data. The message signal of the amplitude AM, it's equal to 10 volt. So this is the amplitude of the message signal, it's equal to 10 volt, and frequency it's equal to 1 kilohertz. The frequency of the message signal FM is equal to 1 kilohertz, it's equal to 1000 hertz. So then they are given frequency sensitivity constant KF. The KF it's equal to 40 hertz per volt. So we have to find out the frequency deviation. We know that the frequency deviation delta F it's equal to KF into AM. So KF is the sensitivity factor and AM is the message signal amplitude. So here KF it's equal to 40 Hz per volt and AM it's equal to 10 volt. So then you substitute AM values and KF into a equation. So after simplification, so we get frequency deviation or change of frequency it's equal to 400 Hz. Then we have to find out the modulating index. So we know that modulation index beta we represent in terms of beta. So beta it's equal to frequency deviation divided by Fm. So it's equal to, we know the frequency deviation is equal to 400 Hz, and Fm is the modulating signal frequency, it's equal to 1000 Hz. So 400 Hz divided by 1000 Hz, we get 0.4. So modulation index, it's equal to zero point 0.4. So zero point 0.4 is the less than 1. It indicates a narrow band FM. So FM we divide into two type based on beta factor. So beta value is less than 1, we called as a narrow band, is greater than 1, we called as a wide band. So here beta it's equal to zero point 0.4, it indicates a narrow band FM. The given problem is a modulating signal m of t it's equal to 10 cos 10,000 pi t modulates a carrier signal AC cos 2 pi fct. Find the frequency deviation and modulation index of the resulting FM signal. Use kf is equal to 5 kHz per volt. So the given modulating signal m of t is equal to 10 cos 10,000 pi t, and carrier signal C of t is equal to AC cos 2 pi Fc into t, and their given sensitivity factor Kf is equal to 5 kilohertz per volt. So first you list out the given datas. So they are given m of t is equal to 10 cos 10,000 pi t. Using this equation we have to find out the amplitude of the modulating signal and frequency of the modulating signal. So we know that m of t it's equal to am into cos 2 pi fm into t. So they are given m of t is equal to 10 cos 10,000 pi t. Just you compare given equation with the standard equation. So we get am it's equal to 10. So message signal amplitude am is equal to 10 volt, and frequency, so 2 pi fm of t it's equal to 10,000 pi t. So here we have to find out the fm. So fm it's equal to 5,000 hertz. So here 2 pi and here pi get cancelled. So 10,000 divided by 2, uh, we get the 5,000, and t get cancelled. So fm it's equal to 5,000 hertz, and they are given sensitivity factor kf it's equal to 5 kilohertz per volt. So we have to find out the frequency deviation and modulation index. The frequency deviation or change of frequency delta f it's equal to kf into am. So we know that kf is equal to 5 kilohertz per volt, and am it's equal to 10. So we get delta f is equal to 50 kilohertz. So this is the frequency deviation. Then we have to find out the modulation index. So modulation index beta it's equal to frequency deviation divided by fm. So it's equal to, so we know that delta f is equal to 50 kilohertz divided by fm. So fm is equal to 500 hertz. So just you replace delta f into equivalent value and fm into equivalent value. So it's equal to 10. So modulation index it's equal to 10 is greater than 1. So greater than 1 is indicates a wideband frequency. Thank you.